The purpose of this presentation is to provide an overview of the Enhanced Watershed Management Programs, or EWMPs, being implemented in the LA region in accordance with the Los Angeles Regional Stormwater Municipal Separate Storm Sewer System, or MS4, permit, and the Program Environmental Impact Report, or PEIR, that is being prepared to assess the potential environmental impacts from the implementation of the Enhanced Watershed Management Programs. This presentation is part of the Notice of Preparation for the PEIR, the Program Environmental Impact Report. The Notice of Preparation, or NOP, was distributed to over 700 stakeholders in the LA region on August 25, 2014. 3 scoping meetings where this presentation was given were held on September 9th, 10th, and the 15th in Marina del Rey, Alhambra, and Monrovia, respectively. The Los Angeles County Flood Control District is leading the Program Environmental Impact Report preparation. The purpose of these scoping meetings is to present this overview and to accept comments from the public on the Notice of Preparation. The public comment period for the NOP has been extended to an additional 30 days to October 29th, 2014. Comments may be submitted to the Los Angeles County Flood District, and the contact information for the Flood District will be provided later in the presentation. The Los Angeles County Flood District is leading the preparation of the Program Environmental Impact Report, or PEIR. The project manager for the Los Angeles County Flood District is Greg Miguel. The Flood Control District has contracted the firms of Weston Solutions and Environmental Science Associates to prepare the PEIR. The agenda for the scoping meeting is as follows. We'll first provide an overview of the Municipal Separate Storm Sewer System, or MS4, discharge permit, and specifically the requirement for the implementation of the Enhanced Watershed Management Program and the development of Enhanced Watershed Management Program plans. We will also discuss the role of the Los Angeles County Flood Control District in the implementation of this program. We'll also provide an overview of the California Environmental Quality Act, CEQA, and the process, and the specific issues to be analyzed in the Program Environmental Impact Report, the PEIR, for the Enhanced Watershed Management Program. We'll also discuss the CEQA schedule and opportunities for public comment through the PEIR process. The proposed project for which this Program Environmental Assessment Report, or PEIR, is being prepared is the Enhanced Watershed Management Program, or EWMP. The purpose of the EWMP is compliance with the Municipal Separate Storm Sewer System, or MS4 permit that has been recently reissued by the Los Angeles Regional Water Quality Control Board in 2012. The goal of the EWMP is to meet water quality goals through the implementation of watershed control measures that reduce pollutant loadings from stormwater and non-stormwater flows, as well as stormwater volumes contributed by the MS4. Each permittee is responsible for meeting these water quality goals for their MS4 discharges within their jurisdiction. The reissued MS4 permit allows for compliance with these water quality goals through either effluent limitations at the MS4 discharge or through the implementation of the EWMP per the schedules and measures defined in the plans. The development of the EWMP plans allows for collaboration and cooperation between permittees in the implementation of these watershed control measures. However, the implementation of watershed control measures will be the responsibility of the jurisdictions that are defined in the plans. The Los Angeles Regional Water Quality Control Board will have the final approval of the EWMP plans. The Enhanced Watershed Management Program, or EWMP, provides for the collaboration among agencies across the watershed to promote more cost-effective and multi-beneficial water quality improvement projects to comply with the MS4. It also allows for the development of watershed-wide programs that will increase water conservation and remove or reduce pollutants from the urban runoff in a cost-effective manner. Enhanced watershed management programs will be implemented in 12 defined EWMPs. Each of the 12 EWMPs will be preparing an EWMP plan that will identify watershed control measures such as structural best management practices, BMPs, or non-structural BMPs to meet the overall water quality goals. Each EWMP will also be conducting a reasonable assurance analysis. The reasonable assurance analysis is conducted using a model that assesses the effectiveness of the implemented and planned BMPs to meet the overall water quality goals. It essentially answers the question, will the watershed control measures defined in the EWMP plans meet the pollutant reduction and water quality goals required in the permit, as well as in total maximum daily loads, or TMDLs, for each watershed. The EWMP plans also provide priority ranking of pollutants to allow for the effective use of resources, and it also defines who will be implementing each of the watershed control measures as defined in the plans. This figure shows the area covered by the 12 participating EWMP groups. 12 EWMP groups have submitted notice of intent for preparation of EWMP plans. This figure shows those 12 groups. They include the Ballona Creek, Beach Cities Watershed Management Group, Dominguez Channel Watershed Management Group, Malibu Creek Watershed, Maria del Rey, North Santa Monica Bay Coastal Watersheds, Palos Verde Peninsula EWMP Agencies, Rio Honda San Gabriel River Water Quality Group, Santa Monica Bay Watersheds, Jurisdiction 2 and 3, Upper Los Angeles River Watershed, the Upper San Gabriel River, and finally the Upper Santa Clara River Watershed. Areas outside of the EWMP groups are completing watershed management plans, which are separate from the Enhanced Watershed Management Program and comply also with the MS4 permit. This table provides a listing of the 12 participating EWMP permittees, both the group name and the permittees involved in each of the EWMP groups. These groups correspond to the graphic shown previously in terms of the EWMP regions that are participating in preparing EWMP plans. The Program Environmental Impact Report, PEIR, is being prepared in accordance with the California Environmental Quality Act, or CEQA, which has 3 key elements. Disclosure. The CEQA process provides for the identification of impacts to the environment due to the proposed project, in this case, the EWMP, which is the Enhanced Watershed Management Program. The PEIR will provide analysis of the potential impacts from this overall project at a program level. The CEQA also provides through the PEIR a decision-making tool. This report will inform the public and decision makers about the potential environmental impacts associated with the implementation of the project. And finally, it will identify mitigation. Where there is a significant impact identified, it will identify ways to avoid or reduce those potential impacts. Further discussion of the CEQA process will be provided later in this presentation. Why is the Los Angeles County Flood Control District leading this Program Environmental Impact Report, or PEIR, for the EWMP? First, the Los Angeles County Flood Control District operates and maintains flood control facilities in all the 12 EWMP groups. The Flood Control District also has a vested interest in increasing opportunities for stormwater capture and groundwater recharge. One of the missions of the Flood Control District is stormwater conservation, which is consistent with these projects that capture stormwater and recharge it into local groundwater. The Flood Control District is also working with permittees and other stakeholders in all the 12 EWMP watersheds to identify potential projects. The Flood Control District has also identified that the proposed projects under the EWMP may have an environmental impact. For all these reasons, the Los Angeles County Flood Control District is leading this PEIR. An important aspect of the EWMPs is that they will be implemented by each permittee within their own jurisdiction, and each permittee is responsible for compliance of their MS4 discharges within their jurisdictions. The EWMPs do provide an opportunity for cooperation and collaboration among the permittees for larger projects. However, the responsibility and implementation of each of the projects will depend on the type of project being implemented. These will be defined in the EWMP plans with regard to the role and responsibility of each permittee in the implementation and operation of the projects. Therefore, as defined in the PEIR, each of the permittees is defined as an implementing agency, and they will vary depending on each individual EWMP project. The proposed project objectives are the achievement of water quality performance goals through the implementation of the Enhanced Watershed Management Program. The implementation of the EWMP will meet regional compliance with the MS4 permit through the coordination and implementation of the compliance strategies and specific projects defined in the EWMP plans that are currently being prepared by the 12 EWMP groups. In each of these plans, the watershed-specific compliance strategies are defined with the specific projects and schedules to implement these projects. The EWMP provides for environmental responsible opportunities that include the implementation of not only water quality benefits, but also other beneficial benefits that include flood control, water supply, and habitat. The proposed project, or the EWMP, includes the implementation of watershed control measures. Watershed control measures may include structural BMPs or physical control measures that generally are consist of these three elements: infiltration, water quality treatment, and storage. The examples that are shown on this graphic demonstrate each of these different functions. The first one includes the storage and containment of stormwater that is then allowed to infiltrate and recharge the groundwater. The middle graphic shows the storage and containment first of the stormwater that is then filtered through a treatment wetland system or a multimedia filter that is then collected in an underdrain system and either discharged to the receiving water or back into the MS4 after this treatment. The third example below shows the temporary storage of stormwater that allows for large debris and trash to settle out as well as sediment prior to the discharge back to the MS4 or the receiving water. There are three categories of structural BMPs that are presented in the Program Environmental Impact Report, PEIR. These include regional, centralized, and distributed structural BMPs. Each of these categories will be presented in more detail in this presentation with examples. Watershed control measures can also include non-structural BMPs. Regional EWMP projects. Regional structural BMPs are unique in that they must retain on-site all the runoff from the 85th percentile 24-hour storm event for a tributary drainage area. The 85th percentile 24-hour storm event is statistically derived and is equal to approximately 1.5 inches rainfall in the LA region. What this means is these projects must retain on-site all storms 1.5 inches or less, and must either then retain and infiltrate that to recharge local groundwater, or it must retain and then use that stormwater in a beneficial manner. Because of the required size of these projects are typically on public lands with open space and may include parks, large parking lots, or vacant space. They may either be above ground retention basins or below ground vaults that then allow for infiltration of this contained stormwater or use in a beneficial manner. An example of a regional EWMP project is shown here in the Sun Valley Park Treatment System. This is an underground retention and infiltration system. As shown here on the left, during the construction of the project includes the diversion of water from the MS4 system into a series of settling and filtering devices or pre-treatment systems prior to it then discharging into two large underground vault systems that allow for then the stormwater to infiltrate and recharge local groundwater. This is an underground system that has temporary construction impacts, but then does not impact the long-term use of the site, which here is a recreational facility. This slide shows additional photographs of the Sun Valley Park Drainage and Infiltration System, which is an example of a regional structural BMP. In the upper left and the lower right shows the construction of the underground vault systems. These vaults will capture and store stormwater and then allow it to infiltrate and recharge the local groundwater. In the upper right and lower left shows the site after the construction has been completed and the restoration of the site for recreational uses as a recreational park. Improvements to the park also include the addition of ball fields, bleachers, and field lights. These additional amenities were added as part of the overall project and demonstrate that these regional structural BMPs may include additional benefits, which will include enhancement to recreational facilities as well as recharging the local groundwater. In the lower left shows an example of educational opportunities at these projects as well, which demonstrates the use of low-impact techniques, which include bioswales and bioretention areas, which filter and cleanse stormwater coming from parking areas. Shown here on this slide is potential expansion of the Sun Valley project to the left. This expansion would allow for additional retention of stormwater and infiltration as part of a larger regional project. Depicted here conceptually is the expansion of this project to include large retention areas of stormwater, which would allow for more capture and storage that could then be directed to the underground vault system that is already in place to allow for additional recharge to the groundwater. These projects provide for additional benefits that include flood protection, recreational improvements, and habitat restoration. Centralized structural BMPs are constructed structural practices intended to treat runoff from a contributing area, generally of multiple parcels. Because these projects collect storm water from larger drainage areas, they're generally installed on larger public parcels and adjacent to storm drain outflows or receiving waters. Examples of centralized structural BMPs include bioinfiltration BMPs, constructed wetlands, treatment BMPs with low-flow diversions, and creek and river restoration projects. Centralized structural BMPs differ from regional structural BMPs in that they do not have to retain on-site the 85th percentile 24-hour storm event. They may therefore use filtration and other treatment processes and release then that smaller retained storm event back into the MS4 or to the receiving water. An example of a centralized structural BMP is the Tahunga Wash project. Here, shown to the left, the before, and to the right, the after shots of this project. The project included transforming a line channel into a more naturalized stream feature that allowed for both biofiltration and infiltration of stormwater flows. This allowed for filtering and treatment of pollutants in stormwater for improved water quality, as well as additional benefits of flood control and habitat improvement. Another example of a centralized structural BMP is the Dominguez Gap Wetlands Project. Shown to the left, the site existed as both a dry weather and a stormwater flow conveyance channel, which was then converted, as shown on the right, to a wetlands treatment system, which filters both dry flows and stormwater flows using natural processes. This project is an example of a centralized structural BMP that has multiple benefits that include not only water quality improvement, but habitat enhancement. Another example of a centralized structural BMP is the Marie Canyon Low Flow Diversion Project located near Pepperdine University. This project diverts dry and low flow storm events and treats them prior to being discharged back to the MS4. Shown here are project photos from the Marie Canyon Low Flow Diversion Project, which is an example of a centralized structural BMP. Shown in the lower right is the pneumatic operated spillgate weir plate that diverts low flows into then a series of treatment processes. These treatment processes remove sediment and bacteria through activated media filter and ultraviolet disinfection, prior to then it being dished back to the MS4 and the receiving waters. The third type of structural BMPs are distributed structural BMPs. These are BMPs that treat runoff close to the source and are typically implemented at a single or a few parcel level. As the name indicates, these BMPs are distributed typically throughout the urbanized environment, which replace impervious surfaces with pervious surfaces as part of a low-impact development approach to reducing pollutants in stormwater. Examples of green infrastructure low-impact development distributed BMPs are listed here, and they include bioinfiltration, bioretention, bioswales, green streets, rainfall harvesting, and planter boxes, among others. Distributed structural BMPs may also include flow-through treatment BMPs. These are typically installed within the MS4 system and may include media or filter cartridges installed within catchments that collect and treat and filter stormwater with the MS4. Distributed structural BMPs may also include source control treatment BMPs that are installed again generally within the MS4 system and may include catch basin inserts and screens for trash, gross solids removal devices, and hydrodynamic separators which remove large debris and sediment from stormwater prior to it then discharging back into the MS4 system. Examples of distributed structural BMPs are shown here in these three figures. The first one in the upper left shows a retention basin constructed adjacent to a highway or road system that will retain stormwater for a short period of time, allowing for the settlement out of large solids, debris, trash, and sediment prior to discharging back to the MS4. Another example of distributed structural BMPs, as shown to the right, is a bioretention or biofiltration area adjacent to a roadway or parking area that collects stormwater from these impervious surfaces and filters them through soil or a filter media that is then collected in a underdrain system below the media and then returned back to the MS4 or discharged to receiving water. Distributed structural BMPs may also include rainfall harvesting in cisterns or rain barrels, or the use of green roofs to then allow for the collection, filtering, and reuse of stormwater as part of the overall green infrastructure. Shown here is an example of a distributed structural BMP in the Valida Greenway project, which was completed in 2009. At this site, an existing flood easement was used to increase stormwater filtering and infiltration by replacing low permeability soils with a bioswale and a deep rock swale that allowed for the collection, filtering, and infiltration of stormwater. This improved water quality as well as provided benefit in recreation and beautification of this community area. Non-structural BMPs are also part of the EWMP implementation. Non-structural BMPs, as the name implies, are not typically constructed BMPs, but they are activities or programs that reduce pollutants at the source or address behaviors that result in pollutant loading activities. They help to prevent and reduce runoff as well as pollutant to the source. Examples of non-structural BMPs include irrigation controls to reduce runoff, covering of trash receptacles to reduce potential trash and bacteria loading to stormwater, replacement of brake pads and lead and wheel weights, which may add to the loading of metals into stormwater, pet waste cleanup stations, which address bacteria loading in stormwater, street sweeping, which address sediment and other constituent into stormwater, catch basin cleaning, and downspout disconnect programs. Non-structural BMPs are important in the overall implementation of the EWMP and meeting the overall water quality goals. The Program Environmental Impact Report for the EWMPs will be performed at a program level. This program level assessment will be submitted by the LA County Flood Control District to the LA Regional Water Quality Control Board, who is the responsible agency for approving the EWMPs. A program level assessment is used to evaluate a plan or program that has multiple components or actions. As the EWMP is a program with multiple activities defined in the watershed measures under each of the plans, this program level assessment is applicable to the EWMPs. The PEIR for the EWMPs will therefore focus on the effects of implementing the overall program. Individual projects will be reviewed as they are further developed to determine what, if any, further review under CEQA will be necessary. Shown here is the CEQA process for an EIR and the opportunity for public review and comment. We are currently in the first step of initiating the scoping process. The notice of preparation has been provided and the comment period for the NOP has been extended to October 29th. We encourage comments from the public and we'll provide a contact information at the Flood Control District to provide your comments. Following the NOP is the preparation of the draft PEIR. The team is currently preparing the draft PEIR, which will then be published and a notice of availability provided to the public. At that point, a series of public meetings will be held and public review and comment period will be allowed during a 45-day period after the draft PEIR has been made available. Comments from the draft PEIR will be responded to, and these responses and along with the comments will be provided in the final PEIR prior to a certification process for this document. The issues that will be analyzed in the PEIR for the EWMP are listed here. Each of these issues will be presented in separate sections. It is a comprehensive list of issues and each of these will be addressed. The issues will be assessed for potential impact, and if a significant impact is identified, mitigation measures to reduce or eliminate that impact will be identified. These will be put in the draft PEIR that will be made public for comment at the beginning of next year. The schedule for the PEIR is shown here. Right now we are in the public review period for the notice of preparation. 3 scoping meetings conducted in September, and as noted, the period for public comment on the NOP has been extended to October 29th. We are now in the process of drafting the PEIR, which will be made available in January 2015 during a 45-day public review period. We will be holding public review meetings to encourage and receive comments on the draft PEIR. In March, final responses to the comments will be prepared and a final PER will be compiled with the responses to these comments. In April, the final PER will then be submitted to the Board of Supervisors for consideration of the project approval and certification of the PEIR. As mentioned previously,